Hi friends, this video is made in a very simple way so that students from even ITI level can understand this. You know that current, what is current? It is flow. Like water flow, in electric, current means flow of electrons. Electrons are part of atoms. So, we will start from atom. In the center of the atom is the nucleus, which contains protons and neutrons, and around this in shell the electrons are revolving. The size of an electron is very much smaller compared to protons or neutrons. Protons are positively charged while electrons are negatively charged. The number of protons will be equal to the number of electrons. That means positive charge and negative charge will be equal, so that as a whole the atom will be having no charge, neither positive or negative. So we have seen that an atom consists of a massive core nucleus in the center containing protons and neutrons. Electrons move around the nucleus in orbits at a larger distances as compared to the size of the nucleus. Electrons are negatively charged with a charge equal to minus E is equal to minus 1.602 into 10 raised to minus 9. It is having a mass of 9.11 into 10 raised to minus 31. Protons are positively charged with a charge same as that of electrons, while neutrons carries no charge, that is, its mass is almost the same as that of a proton, but it has no charge, neither positive or negative. Now take the case of a copper atom. It is having 29 electrons revolving in the shell and 29 protons in the nucleus. These 29 electrons are revolving around the nucleus. In the first shell there are 2 electrons, in the second 8, in the third 18, and there is only one in the fourth shell. See, this electron is loosely held and it is free to move away from this shell, while atoms in the shell nearer to the nucleus are strongly bound. So we have seen that in the case of a copper atom, the number of electrons is equal to 29 and the number of protons is equal to 29. So as electrons, which is negatively charged, and protons positively charged are equal in number, there is no charge in that atom. See, suppose from this outer shell I am removing one electron away from this atom. Now number of electrons becomes 28 and the number of protons becomes 29. That is, number of protons is greater than number of electrons. That is, positive charge is more. So the atom becomes positively charged. Now in the earlier copper atom, if I am adding one more electron in the outer shell, now the number of electrons are more. That is, number of electrons is equal to 30 and the number of protons is equal to 29. That is, electrons are more than protons. So atom becomes negatively charged. Consider the case of 2 balls or balloons which are positively charged hanged from the ceiling. This is charge Q1 while this is charge Q2. As both are positively charged, they will try to repel each other. Now consider the case of 2 negative charges. In this case also, as both are of the same type of charge, they will also repel each other. That is, like charges repel each other. Now if we take the case of a positive charge Q1 and a negative charge Q2, we can see that they are attracting each other. That means unlike charges attract each other. So we have seen that like charges repel each other while unlike charges attract each other. Charge is denoted by Q and its unit is Coulomb, denoted by capital C. The force of attraction or repulsion between two charges Q1 and Q2 separated by a distance of r meter is proportional to product of the charges divided by r square. To make proportionality equal, we need a constant. Here the constant is 1 by 4 pi epsilon, where epsilon is the absolute permittivity of the surrounding medium given by epsilon is equal to epsilon 0 into epsilon r, where epsilon 0 is the permittivity of free space, that is 8.85 into 10 raised to minus 12 Faraday per meter, and epsilon r the relative permittivity of the medium. Force of attraction or repulsion between two charges Q1 and Q2 separated by a distance r is equal to 1 by 4 pi epsilon into Q1 into Q2 divided by r square Newton. Seen in the pond, as there is no force, there is no way for the water or fishes to move in a particular direction. That is, water and fishes are moving in different directions, sometimes towards right, sometimes left, top, bottom, etc. For the water to move in a particular direction, either some path must be provided with some force. This type of movement, having no directions, is called random motion. Same is the case of free electrons, which are randomly moving inside the conductor. If the water is stored at a height and path is made for flowing, or a water pump is provided, it will start flowing. The more the height, the more will be the flow. Similarly, if one battery is connected to the conductor in which free electrons are there, the electrons will start moving and the speed of the movement will be directly proportional to the battery voltage. We know that electrons move from negative terminal of the battery to the positive terminal, which is actually happening. Electrons having negative charges moving from negative terminal to positive terminal through the circuit can be explained in another way, that positive charges are moving from positive terminal of the battery to the negative terminal, which is called conventional current. Anyway, theoretically, both ways of expressions are the same. That is, electron flow from negative to positive, or conventional current, that is positive charges from positive terminal to negative. Even though both are same, in most cases we are considering conventional current or simply current. From these discussions, we understood that for the movement of charge from one point to other, some force is required. This force is called EMF, that is electromotive force. Here, that electromotive force is generated by the battery. Unit of electromotive force is volts. V. Voltage is the potential difference between any 2 points in a circuit. In this case, lamp 1 and lamp 2. Voltage across lamp 1 is V1 and voltage across lamp 2 is V2. Unit of voltage is also volt, indicated by V. Here, current I is equal to dq by dt. That is, current is the rate of change of charge. If Q is the amount of charge flowing through a conductor in t seconds, then current I can be expressed as I is equal to Q by T, where current I is in ampere, charge Q is in Coulomb, and time T is in seconds. A current carrying element is shown in figure. The two ends are A and B, where A is positively charged and B is negatively charged. The voltage between A and B is VAB. For moving charges from positive end A to negative end B, work is to be done. W is work done in joule and Q is in Coulomb. So voltage VAB is equal to work done divided by Q, where W is in joules and Q in Coulomb. The rate of doing work is called power P. Its unit is joules per second or watts. The power in circuit with voltage V and current I is P is equal to V into I. Power is equal to voltage into current. When a voltage of 1 volt is applied across a conductor, causes a current of 1 ampere to flow through it, the power developed is 1 watt. Earlier, as in the case of that waterfall, the flow of water current is directly proportional to the height from which it flows. Similarly, in the case of current is directly proportional to V. Current I is directly proportional to voltage V. This is called Ohm's law. I is proportional to V or V is proportional to I. So, to make that proportionality equal, we need a constant. Here the constant is resistance. So, the equation can be written as V is equal to R into I or I into R. In good conductors like copper, aluminum, etc., resistance will be less so that more current will flow, while in bad conductors like plastic, glass, porcelain, etc., the resistance is more, so current will not flow through it. The SI unit of resistance is ohm. As per Ohm's law, V is equal to I into R, or I is equal to V by R, or R is equal to V by I. If a voltage V is applied to a resistance connected across this voltage, a current will flow through that resistance. The amount of current flowing will depend upon the value of resistance and voltage. See the same thing in that graph also. 1 ohm is defined as that resistance when 1 ampere flows through it when a voltage of 1 volt is applied across its terminals. We have seen that resistance is the opposition to the current flow, while conductance is opposite to that of resistance. That is, conductance is equal to 1 by R. Unit of conductance is mho or Siemens. See this problem. What is the resistance of a 60 watt lamp when it is connected to a 12 volt power source? What amount of current will flow? If the actual voltage is only 11 volt, how much energy would it consume for 100 hours? We know that power P is equal to V into I, that much watts. Or P is equal to V into V by R. Therefore, R is equal to V square by P. That is equal to 12 square by 60, that is 144 divided by 60. This gives 2.4 ohms. From Ohm's law, I is equal to V by R. That is equal to 12 divided by 2.4. This gives 5 ampere. When it is connected to 11 volt supply, power P is equal to V square by R, that is 11 square divided by 2.4 4, that is equal to 121 divided by 2.4, that is 50.4 watts. For a period of 100 hours, energy consumed is W is equal to P into T, that is 50.4 into 100 hours. This gives 5040 watt hour. Dividing by 1000, this will become in kilowatt hour, that is equal to 5.04 kWh, kilowatt hour. I think this video might have been useful to you. If so, please like it, share it, and don't forget to subscribe it.